Okay, so just to help you to understand the process of completing the square even further, right, let's do the same process on this function, right? So this function over here is f of x is equals to 3x squared minus x plus 4, right? We want to change this into the form f of x is equals to a into x minus p all squared plus q. Right, so we want to go from the standard form of our parabola to the vertex form. Okay, now we're going to do that by introducing this bracket, right, which is a binomial, right, squared. Okay, now before we can introduce that bracket, we need to make sure that the coefficient on our x squared term, right, is 1, right. We can see that it's not 1 currently, it's currently a value of 3, right? So we need to factor out this value of 3, right? So when we factor out that value of 3, we will have f of x, right, is equals to 3 into x squared minus 1/3 x plus 4 over 3. Okay, right. So now what we have is that the coefficient on our x squared term is equals to 1, right? So now we can actually start the process of completing the square, right? So let's write down our template, right? Because we know at the end of the day the equation is going to look like this, right? So basically we're going to have f of x, right, is equals to 3, we'll open our brackets, right, and then we'll have this binomial squared, right. Let's leave a space. Okay, I'll tell you now why we're leaving a space, and let's bring this positive 4 over 3 down. Okay, right, so now let's fill in our template, right. So what's going to go into our template is basically an x term, right, and then we need a value of p, right. Now that value of p is going to come from this x term, right, from our original function, that the one that's inside the bracket, right, and we need to take half the coefficient of the x term, right. So the coefficient on our x term is currently a negative 1 over 3, right, and we need to take half of that, right, so that means dividing this fraction by 2, but that's the same as just multiplying this by 1 over 2, right, so by 1/2. Okay, now to multiply fractions, you just multiply the numerator with the numerator and the denominator with the denominator. Okay, the signs, right, in terms of the signs, you have a negative times a positive, so that's going to be a negative. Okay, then we have 1 times 1, that's a 1, divided by 3 times 2, that's a 6. Okay, now this value, right, is what goes in here, that's your p-value, right, so negative 1 over 6. Okay, now what about what must come into this space over here? Well, what has to come over here is the opposite of what you get when you expand this out, right? So when you expand this binomial out, right, you'll get an x squared term, right, and you'll also get this negative 1 over 3 times x term, right? But something else that you're going to get is this negative 1 over 6, right, squared. Okay, so when you square this, right, then you'll have a positive 1 over 36. Right, now this positive 1 over 36 is something that's foreign to this equation, right? So we're going to compensate for that by subtracting subtracting 1 over 36. Right, so this binomial, when you square it out, it's going to give you a positive 1 over 36. We compensate by subtracting out that 1 over 36 to keep everything in balance. Right, so now we can just continue simplifying, right? And in order to simplify this, we need to evaluate these two fractions, right? So let's do that. Okay, so we need to evaluate negative 1 over 36 plus 4 over 3. Okay, so our lowest common denominator is a 36, so which means that we need to change the second fraction to have a denominator of 36, sorry. So we'll have negative 1 over 36 plus, well, what times what number times 3 will give us 36? Well, that's a 12, so 3 times 12, which means that we're going to have 4 times 12 on the numerator. Okay, then we can continue simplifying, so negative 1 over 36 plus 4 times 12 is 48 divided by 36. Okay, and then we now have the same denominator, so we can write that down, which means that we can proceed to just simplifying the numerator. Okay, so on our numerator we have a negative 1 plus 48, which is just 48 minus 1. That gives you a value of 47. Okay, so now this is what we are going to add in our next step, right? Because that's the simplification of these two fractions. Sorry. Okay, so we're going to have f of x is equals to 3 into x minus 1 over 6 all squared, right? And this simplified to a positive 47 over 36. Okay, so we're not done yet, right? We still have a step where we need to multiply this 3 back into our bracket, right? So this 3 that we factored out in the first step, we need to multiply it back. Okay, right, so when we do that, we'll have, sorry, f of x, okay, is equals to 3 times x minus 1 over 6 all squared plus 3 times 47 over 36, right? But 3 goes into itself once and goes into 36 12 times. Okay, so this is then f of x is equals to 3 times the bracket x minus 1 over 6 all squared plus 47 over 12. Okay, now that is your final answer. You're done. Okay, so let's quickly talk about this parabola as well, right? So for this specific parabola, right, we see that its y-intercept, okay, is immediately given to us by the standard form of the parabola as a value of 4. Okay, so in coordinate form, that is a coordinate at 0, 4. Okay, that's the y-intercept of our parabola. Okay, from the standard form, we also see that the a value is greater than 0, right? Which means that our parabola is facing upwards. Okay. Then what the vertex form does is that it adds to the sketch the coordinate of your turning point. Okay, and in our case, the coordinate of our turning point is going to be a positive 1 over 6. And as a y value, we have this fraction, 47 over 12. Okay, so if you had to do a quick sketch of this function f of x, you would most probably have to also find the x-intercepts of your function, right? But before you start evaluating x-intercepts, right, I will always suggest to you that you determine your nature of roots. Okay, so the nature of roots is what's going to tell you if it's worth actually going through the process of finding x-intercepts, right? So it tells you whether you have x-intercepts or not, right? So if through evaluating the nature of roots you find that you don't have x-intercepts, then it means that your working out is cut in half, because now you don't have to do that step. Okay, so let's determine the nature of roots for this function. So the nature of roots is given by the discriminant, right? And the discriminant is given by the value b squared minus 4 times a times c. Okay, we get these b, a, and c values, right, from the standard form. Okay, so our b value is a value of minus 1. Okay, so minus 1 squared minus 4 times our a value is 3 and our c value is a positive 4. Okay, now I can already see that negative 1 squared is going to give me a 1, and this over here is something much greater than 1, because 4 times 3 is already 12, right? So this result is going to be negative. Okay, right, so negative 1 squared minus 4 times 3 times 4, whatever this value is, right, this is less than 0. Okay, so then therefore the discriminant is less than 0, right? Now remember that when the discriminant is less than 0, it means that you have no real solutions to your equation, right? But because now our equation is actually a function, right, it means that you have no x-intercepts. Okay, which is nice, because now you don't have to determine the x-intercepts, right? So if you had to do a quick sketch of your function, right, you would have that this is the x-axis, that's the y-axis, right? You know that your function is facing upwards, right, and you need to cut the y-axis at a value of 4, right? So you can quickly sketch it to look something like that. Okay, so this is f, all right, and this point over here is a value of 4, and this point over here is at an x value of 1 over 6 and a y value of 47 over 12. Okay, you can determine these fractions and maybe just round them off to 2 decimal places and write those in as well. Okay, but there you go, that's the quick sketch of your function f of x.